Once in a while, we run across a science story that is hard to believe until you see it. That's how we felt about this story when we first saw human beings operating computers, writing emails, and driving wheelchairs with nothing but their thoughts. Quietly, in a number of laboratories, an astounding technology is developing that directly connects the human brain to a computer. It's like a sudden leap in human evolution, a leap that could one day help paralyzed people to walk again and amputees to move bionic limbs. As we first reported last November, the connection has already been made for a few people, and for them, it has been life-changing. Scott Mackler was a husband, father, and successful neuroscientist when he received perhaps the worst news imaginable. At the age of 40, he could run a marathon in 3.5 hours, but it was about that time that he discovered he had ALS, Lou Gehrig's disease. His brain was losing its connection to virtually every muscle in his body. The near total paralysis would also stop his lungs. He didn't want to live on a ventilator, so 9 years ago, he recorded this message for his 2 sons.
I know the future holds lots of love and joy and pride, and life goes on, and I'll be watching you along the way. And I love you very much, and I'll see you.
This is Scott Mackler today. His mind is sharp as ever, but his body has failed. Doctors call it locked-in syndrome. Scott and his wife Lynn learned to communicate with about the only thing he has left, eye movement.
He'll look at you for yes,
right,
and for no.
And for no, he looks away.
Yeah.
I see. It's cumbersome.
It is.
But recently, Scott found a new voice.
Can everyone hear the PC? I apologize for the quality of the voice.
Scott wrote these words one letter at a time with nothing but his thoughts and the help of what's called a brain-computer interface, or BCI. He wears a cap that picks up the electrical activity of his brain and allows him to select letters simply by thinking about them. Then the computer turns his sentences into speech.
I hate being helpless, and when other people put words in my mouth.
Well, this is a very unusual interview for 60 Minutes. We've done something that we never, ever do, and that is we've submitted the questions in advance because it takes Scott a little while to put the answers together using the BCI device. Scott, I understand that earlier in the progression of this disease, you said that at the point you had to go on a ventilator, you didn't want to go on anymore. But today you are on a ventilator, and I'm curious about what changed your mind.
Because I can still communicate.
It isn't fast. It takes 20 seconds or so to select each letter. Scott told us it took him about an hour to write the answers to our 16 questions. But he writes well enough to continue his research and manage his lab at the University of Pennsylvania, where he still goes to work every day.
You use this system even to text your sons, for example. And I wonder what it would mean to your life today if the system somehow was taken away from you.
I couldn't work without BCI.
Couldn't work without BCI. What has it meant to your relationship?
Well, he's happier. He can communicate with not just us, but with the world. This gave him his independence, his working, intellectual, scientist independence back.
The system was developed by neuroscientist Dr. Jonathan Wolpaw at New York State's Wadsworth Center.
This is basically a standard EEG or brainwave cap.
To understand how the BCI works, I asked researcher Teresa Vaughn to hook me up.
And you'll see their little white discs scattered around on your head.
Those discs are electrodes that pick up the faint electrical activity that brain cells create when they communicate with each other.
Yeah.
Sorry.
It's a little cold.
Teresa is putting a conductive gel on top of my scalp to help the electrodes pick up the signals.
All set?
All set.
I'm thinking of the letters of a word that only I know. Every time the computer flashes the correct letter on the screen, I silently think to myself, that's it, that's the one. That feeling of recognition sets off a unique electrical pattern in my brain, which the computer picks up.
This is remarkable.
It worked the first time I tried it. without a single mistake.
That is amazing. How about that? How about that? I never would have believed it. You know, I can imagine some people watching this interview are thinking to themselves, wait a minute, they're connecting the brain to a computer. Are we moving in the direction of reading people's thoughts?
Yeah,
Is this mind control around the corner?
No, it's not. It's certainly not mind control, and it's different from reading people's thoughts. It's important to realize that this requires the cooperation of the person.
As remarkable as this is, some scientists believe this technology is limited because putting electrodes on top of the scalp is like listening to a symphony from the street outside the concert hall. So what would happen if the electrodes were inside the brain? That's what they're doing at the University of Pittsburgh, implanting electrodes inside the brains of monkeys.
This is an array.
Andy Schwartz, a neuroscientist at the university, implanted this grid of electrodes. It's tiny, but there are 100 sensors, each listening to a different brain cell or neuron. It's like listening to the symphony of the brain, but now sitting in the front row. Tell me what we're hearing.
Right there, you're hearing the cell fire.
The brain is telling us how it works. We just have to figure out the language. Schwartz has been decoding that language by watching the monkey's movement and recording the corresponding signals in its brain. So what does that tell you?
So there's a relationship between how fast the neuron fires and the way the animal moves its hand. And we're trying to understand that relationship so that if we see a neuron firing, we can say, the animal's about to make this kind of movement.
Once Schwartz started to figure out that relationship, he was able to connect the monkey's brain directly to a robotic arm. Within days, the monkey operated the arm as if it was his own.
The monkey has both arms restrained, and we're recording brain signals from its brain, and it's using those brain signals to operate this entire arm.
So he's operating the arm in 3 dimensions, up, down, forward, and back.
As well as the gripper.
Well, what you're telling me is that the monkey is operating this arm with nothing but his thoughts.
Absolutely. Now, you see the evidence right there. There's the proof of the principle right there.
What are the chances that a human being would be able to do the same thing?
Oh, we think a human being could do much better.
And believe it or not, Kathy Hutchinson is well on her way to finding out. She's among the first humans to have her brain directly wired to a computer. Years ago, Kathy suffered a stroke that left her mentally sharp but trapped inside a paralyzed body and unable to speak, locked in, like Scott Mackler. 3 years ago, Kathy volunteered to have the same kind of sensors we saw in the monkeys implanted in her motor cortex, which controls movement and is located right on the surface of the brain. The sensors connect to the computer through this plug on her head. The system is called BrainGate, and it was created by a team led by Brown University neuroscientist John Donahue.
If you look at this square, each one of these little black boxes is the electrical signal coming from one electrode in the brain.
And each one of those is a neuron firing.
Right. It's its electrical potential. It lets out a 1,000th of a second pulse.
How well do we understand this language?
We have a somewhat of an understanding. We know that there's a general pattern of, for example, left, right, up, down, even fast or slow.
Scott, Kathy now has neural control over that cursor.
Dr. Lee Hochberg of Massachusetts General Hospital is leading the clinical trial. We watched together as Kathy showed us what she can do. We're seeing Kathy moving this cursor with nothing but her mind.
That's right. She's thinking about the movement of her hand, and she's moving the cursor much as if she had her hand on a mouse.
So if a patient who's paralyzed thinks, move my left arm, the brain fires those neurons.
Yes.
Even though the arm does not move.
Yes, it's very surprising. It fires even though you're not moving.
The cursor's still a little bit wavier. Some days it's,
Moving the cursor with her mind is not as fluid or direct as using a mouse. While we were there, the cursor meandered a bit, sometimes overshot. But Kathy always hit her target in the end.
Do you want to play some music? All right. She'll click on it, imagining squeezing her hand, which is the, or doing something else for the click.
And she just clicked play.
Yep, she did.
That's pretty amazing. And so, I mean, if Kathy can control a cursor, she can control anything a computer is connected to.
That's the goal.
The lights, the temperature in the room, even a wheelchair at some point.
Ready to try it for real?
In fact, Kathy has already driven a wheelchair.
See if you can drive it right over to the door.
They haven't let her ride in it yet for her own safety. But with monkeys adopting robot arms and a completely paralyzed person driving a chair, imagine where this could be headed.
Fantastic. Very good.
You're merging man and machine.
In that sense, yes.
You've done it.
Yes.
Donahue envisions this technology will go beyond helping people communicate. He believes that amputees will one day be using BCIs to control robotic arms, and those with paralysis will be able to move their own arms and legs again.
So in spinal cord injury, that cable that connects the brain to the spinal cord is broken. We can reconnect that brain, not to the spinal cord, but directly out to the muscles with a little computer that's making up for all the lost parts. And we'll see people be able to do things like reach out, hold on to a cup, bring the cup to their mouth and have a sip of water.
As a neuroscientist, Scott Mackler also believes that day will come. His skullcap interface is a machine that has given him back his humanity. He's continued to publish scientific papers and to speak his mind.
Live life to the fullest. My wife and I now speak every day of how we have no regrets.
No regrets.
As our